So this is the Geometry Unit 1 Section 3 video about algebraic proofs. So today we're going to use the properties of equality and use them to write algebraic proofs and identify properties of equality and congruence. So our vocabulary word today is a proof, and in this first blank in your notes it says a proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. Also, an important part of writing a proof is justifications to show that each and every step is valid. So as we work through this one here, we're going to write a step-by-step solution of a linear equation by placing the given equations into the correct order. Well, I'm going to give you the first step because it's where you're going to start. And this one right here, x is equal to 8, is where you're going to end. So go ahead and put these in order. Go ahead, pause the video, put them in order, and then come back to me. Okay, so once you work through this proof or this problem, you would have go ahead and done this right here, and then we would have combined that right there. Then we would have moved this over there. Then we would have gotten rid of that, and that's how we would have gotten here. So let's go ahead and now talk about these properties. So the addition property of equality is if we had a and b and then we added c to both sides, we would get that equals a plus c and that equals b plus c. And in your notes it said what symbol are we talking about, and obviously here we're talking about the addition symbol, the subtraction symbol. Now when we talk about multiplication, there's a couple ways. You could have the times symbol, you could have the dot, you could have parentheses, but you could also have something like 2y. That means 2 times x. Now when we talk about division property, we're talking about either the division symbol, this, or something like that, or again something over something else. That also represents division. So if you look at the actual examples here, then we're talking about if a is equal to b, then a plus c is equal to b plus c. That's where we add c to both sides. For the subtraction property, if a is equal to b, then a minus c is equal to b minus c. We subtracted c from both sides. The third one, which is multiplication, if a is equal to b, then a times c is equal to b times c. And then the fourth one, the division property, is if a is equal to b and c does not equal 0 because we can't divide by 0, then a divided by c is equal to b divided by c. Now we're going to talk about these next three in order. So we have this reflexive property. The reflexive property is best understood by the word reflection. And I say that because I have the same thing you can see here on either side of the equal sign. And when we are dealing with a reflexive property, it has to do with one thing. Okay, now when we move down here to the symmetric property, if you notice, it says if a is equal to b, then b is equal to a. When we talk about that, we're talking about a flip. So that's all the things did on either side of the equal sign is a flip. And this time we're talking about two things. So reflexive is one thing, symmetric is two things. Then the third one down here is the transitive property. It says if a is equal to b, b is equal to c, then a is equal to c. So here, again, this time we're talking about three things, okay? So it could be three or more things. And I'm going to give you a better example of that one a little bit later. And then the substitution property of equality. So that would be a problem like this, x plus 1 equals y, where we're going to substitute in x is equal to 1, and that would mean it would be 1 plus 1, and that means y would be 2. So that's our substitution property. Okay, so then hopefully you guys remember the distributive property. This is when we multiply something times two things that are in a set of parentheses, and we were going to distribute that 3 to both things. So that's going to be 3x plus 3 times 3, which is 9. So that's our example of the distributive property. So now we're going to go back to that original problem that we did, and we're going to look through each of these steps here. So it says, how did you get to step A? Well, I gave you step A, so step A was given. What property do you use to go from step A to step B? This time we're using the distributive property because we distributed that 3 to both the x and the negative 4. With going from step B to step C, we combine like terms. Well, instead of writing out combining like terms, we're going to use the term simplify. So that's what we did there. We simplified the negative 12 plus 5. Now when we go from step C to step D, we're going to add the 7 to both sides. That's the addition property. And finally, when we go to from D to E, we're going to divide both sides by 3. And remember, we're always doing the opposite operation that's there to resolve what's on one side of the equal sign and move it to the other. So if we have multiplication on the left, we're actually dividing to get rid of it. So I'm going to walk you through this one. It says solve the equation 4m minus 8 equals negative 12 and write a justification for each step. So on this one, we were given the first step, and then we would have added 8 to both sides, so that's our addition property. Then our next step here will be dividing both sides by 4, and then again, that gives us m is equal to negative 1. So that's just an example of showing literally every single step that we would have done to process through this problem. Most of you would not have shown this step or this step. You would have just done it. Which means you would have put the addition property of equality and the division property of equality there. The check it out example 1. So I want you guys to go ahead and work this problem and then come back to me when you're done. Okay, so on this one, we've got 1/2 t equals negative 7, and that was given to us. Now to get rid of that 1/2, we're going to have to multiply by its reciprocal, which is 2, and that would be the multiplication property of equality. Now when we do that, we get rid of the 2 and the 1/2 because they cancel each other out, and we're just going to then simplify the 2 times the negative 7. So that's our next step there, simplify. All right, now this one should look really familiar to you guys because it looks a lot like what we did last week. So when we look at the first step of this is our segment addition postulate again. Our second step is just us substituting in the values for NO, NM, and MO. Our third step is simplifying. We combined the 2x plus the 3x. Our next step, we subtracted the 4x from the 5x. And our final step, we're going to add 9 to both sides. So those are our reasons, or our justifications: segment addition postulate, substitution property of equality, simplify, subtraction property of equality, and addition property of equality. This one here should look familiar as well. So I'd like you guys to go ahead and work this one and then come back to me when you're done. So here again, when we start out this problem, our first step is going to be the angle addition postulate. Again, we're going to substitute in the values for each of those angles. And then we're going to simplify. So we added the 3x to the 6x, and we subtracted the 16 from the 5. Then we are going to subtract 9x from 8x. And then I'm going to multiply negative 1 times both sides. You could have divided by both sides by negative 1. And so either multiplication property of equality or division property of equality would work here. So our next one here says, when writing algebraic proofs in geometry, you can also use definitions, postulates, properties, and pieces of information to justify the steps. In this drawing, I see that these two angles are congruent to each other. Now, if this problem said at the beginning of it that angle JKL was being bisected by KM, then I could have also put those arcs there. And so then I could say that the measure of angle JKM is equal to the measure of angle MKL, and that's by the definition of congruent angles, or by the definition of bisect, depending on what the problem told me. Then we're just again substituting in. The next step was subtraction, and the final step was addition. So remember that when we have numbers, like we're given actual number measurements of numbers or values, we use the equal sign. And when we have figures that either have tick marks or arcs, that's when we're going to use the congruent symbol. So now, oops, pause 1 second and let me go fix this. Let's do this again. So this time we're going to talk about the property. We're going to talk about the symbol that's represented by those properties. And on your paper, your notes, it actually tells you that one is congruence and one is equality. And then we're going to talk about an example of congruence and an example of equality. All right, so the reflexive property, if you recall, this has to do with one thing. And we said this was a reflection. That's our word. So our symbol for congruence is obviously that. Our symbol for equality is the equal sign. So an example of a congruence problem would be EF. Segment EF is congruent with segment EF. That is the reflexive property because we only have one thing represented here. Now, examples of equality are different. This one we're going to have an equal sign, and when we do this, there is no segment symbol over the top because we know that these things are equal because they have the same measurement, not because we can see tick marks. Symmetric property has to do with two things, and we use the word flip for this one, if you recall. So again, when we're talking about congruence, we're talking about the congruence symbol. Equality is equal. So this time we're going to talk about some angles, and this has to do with two things again. So if we said if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. And what we see here is they just flipped sides from where that symbol is. Now if we talk about examples of equality, this differs because now we have the m in front. So we say if the measure of angle 1 is equal to the measure of angle 2, then the measure of angle 2 is equal to the measure of angle 1. The third one is the transitive property, and this one has to do with three or more things. So, and when I taught it to my students in my class, I literally held up my hands and I talked about R, S, T because those are in alphabetical order, and I put 1 up when I do R, and I put 2 up when I do S, and I do three fingers when I do the transitive property. So 1 for reflexive, 2 for symmetric, 3 for transitive. Here again, our equal sign. Now we're going to talk about some segments and how they relate to each other. So if PQ is congruent to RS and RS is congruent to TU, then PQ is congruent to TU. There should be a line over top of that. Somehow that wasn't there, so that goes there. Now when we talk about equality here, it's very similar. The difference is, again, we don't have the segment symbols over the top. So if PQ is equal to RS and RS is equal to TU, then PQ is equal to TU. I want you guys to notice that our final statement always has to do with the first thing and the last thing. The first thing and the last thing. So that's kind of the way this works. So, and the example that I gave my students in my class was if A was equal to 1 and A was equal to B, then you could say B was equal to 1. And I know most of us do better with numbers. So that was the example I gave my kids in class of the transitive property. All right, so now we're going to identify these. So identify the property of equality and congruence. So go ahead and work through these and then come back to me when you're done. So number 1 says angle QRS is congruent to angle QRS. So this is the reflexive property of congruence. Again, we have the congruent symbol here and the congruent symbol there. B is the measure of angle 1 is equal to the measure of angle 2, so the measure of angle 2 is equal to the measure of angle 1. We have two different distinct angles here, so this is going to be our symmetric property, and it's going to be equality again because we have an equal sign there. Then for letter C, we have segment AB is congruent to segment CD, and segment CD is congruent to segment EF. So segment AB is congruent to segment EF. Notice here again, we have AB and EF. So that's the transitive property because we have 1, 2, 3 different segments. So this is the transitive property of congruence. 32 degrees is equal to 32 degrees. This again is going to be the reflexive property, but this time it's going to be of equality because we have an equal sign there. Okay, go ahead and see if you can do these and then put me on pause, come back and check your answers. Okay, so on this one, we have that DE is equal to GH, and so GH is equal to DE. Again, we have two things here. So this is our symmetric property, and it's equality, again, because of the equal sign there. We have 94 degrees equal to 94 degrees. This is going to be our reflexive property, again, of equality, because there's an equal sign there. 0 is equal to A, and A is equal to X, so 0 is equal to X. We have 1, 2, 3 distinct values here. So this is going to be our transitive property, and again of equality because we have that equal sign right there. Our final one, angle A is congruent to angle Y. So angle Y is congruent to angle A. So again, we have two things here and they're flipping. So this is going to be our symmetric property of congruence. All right, our last one. So go ahead and do these and come back to me and check them. So this first one, which on your note says A, angle 1 and angle 2 are congruent, and angle 2 or 3 are congruent, so angle 1 and 3 are congruent. This is going to be our transitive property of congruence. For B over here, if angle ABC is congruent to angle DEF, then angle DEF is congruent to angle ABC. This is going to be our symmetric property of congruence. Again, we got the congruence symbol here, and two things that just flip positions. Here we have segment WX is congruent to segment WX. This is going to be our reflexive property of congruence. Again, that's our congruence symbol there. And then we have if FG is equal to HJ, then HJ is equal to FG. This is going to be, again, the symmetric property of equality and equality because of that equal sign right there.